All right, hello everybody, and welcome to your Unit 1, Section 2 notes, Part 2. So far you should have completed the notes on pages 1 and 2 of the Section 2 green sheet. They should look like this, except all filled out. And then you should have already completed page 4 in Section 2, the table, and the Venn diagram. All right, and we'll go over those in class. All right, so I want you focusing on page 3 for right now as I go through the PowerPoint. All right, so what you see right here pictured is the heating curve of water. So as we are going up, we are increasing in temperature, and as we're going across, we are increasing in time. All right, so this is showing us, right, as we heat something up, what happens to it. And we're going to talk about what phases of matter are at each spot and what transitions are happening between them, or phase changes. All right, so from A to B, so you should write this underneath of your picture on your green sheet where it says from A to B, and this is a solid. This makes sense because they are typically the lowest, or always the lowest temperature. Think about water, right? When it's super cold, it becomes ice, which is a solid. Right? And now as we heat up that solid, we can raise the temperature until it starts melting. And during that melting process, the temperature levels off. As you can see here, from B to C, we're not increasing upwards, we're just going across to the right. Okay, so the temperature is leveling out until we have all liquid, and our temperature will start to rise again. Right, so you can think about on maybe a hot summer day, you want a very cold glass of water to help cool you down. But in the winter, maybe you want a warm glass of hot chocolate. Right, so we have liquids ranging in temperatures, right? But we can heat them up to a certain temperature, and again, we will have a phase change and the temperature levels off. And we call this evaporation. You can also call this boiling. Both will be acceptable answers for us. Right, so while the liquid is evaporating and becoming our next state of matter, right, the temperature levels off. Right, and finally, we will become a gas, and the gas can continue increasing in temperature. All right, so one quick question for you. At what temperature does water evaporate? Right, so this should be common knowledge for you. Now, this graph is in Celsius, so that might make it a little bit tricky. You might know at what temperature water boils in Fahrenheit. In chemistry class, we're going to stick to Celsius and Kelvin instead of Fahrenheit. All right, so if you answered 100 degrees Celsius, you were correct. Water boils or evaporates at 100 degrees Celsius. Right? So while that water is boiling, right, it will have a constant temperature of 100 degrees until all of it evaporates and the gas can continue rising in temperature. So if this is 100 degrees Celsius, right, where is 0 degrees Celsius at? So where on this chart would we find 0 degrees Celsius? Very good. So if you said right here between B and C, when we are melting, right, you would be correct. All right, so for Celsius, 0 degrees is when water freezes or melts, but in Fahrenheit, we call that 32 degrees or freezing. All right, and one final question for you. Why can steam be more dangerous than boiling water? Right, if you were paying attention a little bit earlier, I think I teased the answer for that. All right, so the answer here is because while water can get very hot, it stops at 100 degrees Celsius. It will not get any hotter. But steam, the gaseous form of water, can reach temperatures much, much higher than 100 degrees Celsius, which can cause much more serious burns than 100 degrees Celsius water. Now, that's not to say that boiling water is not dangerous and hot. Anytime we are boiling water in the chemistry lab, we will be wearing our safety goggles. All right, so we're going to jump down a little bit. So if we were to begin with water vapor, so up at the top where the gases are, right, and remove energy, right? Sometimes we call that making it colder. But as we remove energy instead of adding it, what would happen? So we're going to have the same states of matter, but we're going to have different phase changes because we're going in the opposite direction. So as we remove energy and go from a gas to a liquid, right, that will be condensation. So as gas turns into a liquid, we call that condensation. You might see a water bottle on a hot summer day starting to sweat and have beads of water on the outside. Right? That's condensation. That is gaseous water from the air around us condensating, losing energy, and becoming liquid on the surface of that bottle. All right. Then from D to C as a liquid, right? The liquid will continue to cool down and get colder until it starts to freeze. All right, so from C to B, you'll write in that it is freezing. All right, I don't need many examples for that because I'm sure you often put liquid water in the freezer to become ice cubes. Right? Or maybe you left a bowl of water outside someday, maybe for like a dog or a cat, and came out the next morning and it was frozen solid. All right, and then we can still cool down from B to A, right? Solids can still get colder. All right, so that is it for the notes portion of this. If you need to, you can go back in the video and make sure you have everything right. But I want to show you what you are expected to complete next. So in order to finish out this section 2 notes, I want you to finish page 5 of the Chem2Go section. All right, so you're going to create your own graph just like we had in our notes, so you can use that as a guideline for how to set this up. And then you're going to label, right, the melting points and the boiling points based on where you have those levels off. All right, I want you to do your very best, right? Not trying is not an option here, so I need you to try, and we will go over what the correct answer will be in class. Alrighty. And then don't forget to answer number 4. All right, that's all I got for you. Have a wonderful day. I'll see you later.